Hi everyone! Today we're breaking down one of the most important and sometimes one of the most confusing parts of experimental design, control groups. Specifically, what's the difference between a negative control and a positive control? So let's get into it. So first, let's define what a control group is. A control group is simply your baseline. It is the group that you compare your experimental results against. Without it, you have no way of knowing if your treatment actually did anything. Now, control groups come in two different types, negative and positive. A negative control receives no treatment, or sometimes a placebo, and is expected to show no response. Its job is to confirm that nothing unusual is happening on its own. If your negative control suddenly shows a result, something went wrong, maybe contamination, or maybe there was a confounding variable. On the other hand, a positive control receives a treatment that is already known to work. It's expected to show a clear result. Its job is to verify that your experiment is actually capable of detecting a result in the first place. If your positive control fails, your method or materials may be broken, not your hypothesis. So now, to really solidify our understanding of the difference between a positive and negative control, let's look at 3 real-world examples. Example 1 is testing an antibiotic. So, in this scenario, you want to test whether a new antibiotic kills bacteria or not. In this experiment, your negative control would be bacteria in plain water without antibiotic. Your positive control would be bacteria and a known working antibiotic, such as penicillin or ampicillin. Your experimental group would be bacteria and a new antibiotic. This is what you're testing. In the negative control, we're going to expect for the bacteria to grow as no treatment was given. In the positive control, we expect the bacteria to die, which confirms that our method works. If the negative control shows bacterial growth and the positive control shows bacterial death, your experiment is set up correctly. Now, whatever happens in the experimental group is a meaningful result. Example 2 is testing a fertilizer on plants. In this scenario, you want to see if a new fertilizer helps plants grow taller. Your negative control in this scenario would be plants in plain water only. Your positive control would be plants in a fertilizer that is proven to work. And your experimental group would be plants in the new fertilizer, which is what you're testing. In the negative control, you are expected to see normal baseline growth. This is what you're going to compare your results to. In your positive control, you should see faster or taller growth than the baseline. The negative control tells you how plants grow naturally. The positive control confirms your growing conditions can actually produce enhanced growth. Without the positive control, you may wrongly conclude your fertilizer failed, when really, your setup just couldn't support good growth to begin with. Example 3 is a diagnostic test such as a COVID or pregnancy test. In this scenario, you are running a diagnostic test strip. The negative control would be plain water or a negative sample. The positive control would be a confirmed positive sample. And the experimental group would be the patient's unknown sample, which is what you're actually testing. In the negative control, you expect to see no line appearing on the test strip. On the positive control, you expect to see a line appearing. Here's the cool part. Most home test strips actually have a built-in positive control line. That is the line that always appears whether you're positive or negative. It's just there to prove that the test strip is working. If that line doesn't show up, the test is invalid. So to recap, the negative control shows no treatment and you expect no result. This catches errors and contamination. The positive control is the known treatment and you expect a clear result. This confirms that your experiment actually works. So, controls aren't just extra steps, they're what actually makes your results trustworthy.
And if you've made it this far, this lesson connects directly to 2 of AP Bio's core scientific practices. The first is determining scientific questions and methods. Choosing what controls to include is determining your method. When you're designing a negative control, you're deciding how to rule out error. When you're designing a positive control, you're deciding how to verify your experiment can actually detect a result. Your controls don't come after the question, they're part of how you answer it. The second is argumentation. Develop and justify scientific arguments using evidence. Your controls are what makes your evidence justifiable. If your negative control showed no response and your positive control worked as expected, you can confidently defend your experimental results. Without them, you have data, but you can't fully back it up. Controls are what turn an observation into an argument.
I hope this helps. Thank you for watching and good luck in AP Bio.